Okay, so I'm going to go through some of the basics for the C7 topic in chemistry, which is all about crude oil, hydrocarbons and the reactions of them. Now I've just started here by the very basic definition of crude oil. Crude oil is a mixture of different sized hydrocarbons. So if you can imagine, this is a container of crude oil and I've got different sized hydrocarbons. We say it's a mixture because they are not joined together. These different hydrocarbons are not joined together. So this hydrocarbon here is not chemically joined to this hydrocarbon here, which is not chemically joined to that hydrocarbon there. So what is a hydrocarbon? A definition you need to know. A hydrocarbon is a compound made from, spell that right, hydrogen and carbon only. The word only, very important. So a hydrocarbon, which is one of these, is made up of hydrogen, H, and carbon only. There's nothing else in there. So that's what crude oil is. Now, these different hydrocarbons have different properties, and that's what makes them useful or not very useful. So this small one is very useful, whereas this big hydrocarbon here is not very useful. So we're going to look at why that is shortly, but to start with, we're going to look at how we can separate this crude oil. So this is for a process called fractional distillation. Something that I'm sure you've all heard of, but as I say, I'm just going over the basics just to remind you. So in fractional distillation, we have a giant column. Now you're going to forgive my terrible drawing. I am not good at drawing in the slightest. So this is what a fractional column looks like, very, very roughly. Lots of different tubes coming off. Something like that. Now, this is where our crude oil will enter. So the crude oil enters. Now, something you need to remember about this fractioning column, it is much hotter at the bottom than it is at the top. Much hotter down here, much cooler at the top. So the crude oil will enter, and it enters as a liquid, L for liquid. It enters as a liquid. As it enters, it is then vaporized. It is vaporized, so it turns from a liquid into a gas. It turns from a liquid into a gas. So now what you have is in this column, you've got all these different hydrocarbons, because all these different hydrocarbons were here as a liquid, as a mixture. They've entered, this liquid has now turned into a gas. So now what we have are lots of different hydrocarbons, but now in the gas stage. They're now in the gas state. And they're all spread out. They're all spread out now. And you can see the larger the hydrocarbon, the lower it is in the column. So the larger the hydrocarbon, the lower it is in the column. So there they all are. There's my hydrocarbons, still in the gas. Once they move up the column, this one here, let's look at this one, the smallest one, it's moved up the column as a gas. It is then condensed. And it's condensed because it's met its boiling point. So it condensed at boiling point. So this gas now turns into a liquid because it's condensed. That's what condensed means. Condensed means turning from a gas into a liquid. So it's condensed. It's now in a liquid, and this fraction, we call it a fraction. That's why it's called fractional distillation. So this fraction has condensed at its boiling point, and it's now turned back into a liquid, and it can then be collected. And that's what all these fractions do. They all condense at their boiling points. Anything that doesn't turn into a gas when it enters, because it's too big, is automatically taken off at the bottom. So the main points that you need to know from this are: crude oil is a mixture of different sized hydrocarbons. A hydrocarbon is a compound made from hydrogen and carbon only. We want to separate these hydrocarbons for different uses. And we separate the crude oil by fractional distillation. And in fractional distillation, the crude oil enters a liquid. It is vaporized, which means it turns into a gas. That gas moves up the column. Once it reaches its boiling point, it condenses back into a liquid. Okay, so it enters as a liquid, vaporized, turns into a gas, moves up the column, condenses out as a liquid. Now, what I'm just going to talk about to end with are why. Why do we want to separate the crude oil? Why do we want to separate the crude oil? I'm sorry, for those of you who don't know me, my handwriting is terrible. Why do we want to separate the crude oil? It's because different fractions have different uses. So what this means is that each fraction will have a different use. So we can't use different fractions for the same things. And it's all to do with their properties. So this is a small hydrocarbon. So small hydrocarbons burn very easily. Small hydrocarbons burn very easily, which means they are very good fuels, which equals very good fuels. As you go down and you get a very large hydrocarbon, now I'm not going to put all the H's on. Large hydrocarbons, they don't burn easily. They don't burn easily. So they're not good fuels. Not good fuels. So they're not good fuels. So we want smaller hydrocarbons. Smaller hydrocarbons, very useful. Why? Because they burn very easily. They burn very easily, which is this. They burn very useful, burn very easily. And that is because take little energy to break. Take little energy to break. So the small hydrocarbons, very good fuel, therefore very useful because they burn very easily and they take little energy to break. It's the opposite for the large hydrocarbons. The large hydrocarbons, they don't burn very easily, so they're not good fuels because they take a lot of energy to break. That is the very basics of fractional distillation. That is the very